I hope for nth stationary state you can find expectation x square, expectation p square. That problem is done. Okay. We shall randomly discuss, then I'll try to order this problem into two parts, okay? Nothing special about stationary state, isn't it? That can be done. Example number 2.2. Okay, I told you, I think if possible I'll tell you again. Psi of x comma 0 is equal to a into x into a minus x, okay? If you plot this psi x comma 0, 0 to a, so this is parabola actually, looks like ground state of 1D box, am I right? This is a particle in 1D box, okay? Wave function is like this, it is 0 outside, okay? Psi of x comma 0. It's a function of x. Is that okay? And you can normalize, you can find this normalization constant and all, 0 to a. Outside it is 0, okay? So they mention like this. They mention x is between 0 to a, okay? That means outside wave function is 0, okay? Now look at here, this is a general function, am I right? It's a parabolic function. How this can be the state, isn't it? And we have seen any function can be written in terms of sign, am I right? That means eigenstate of 1D box, isn't it? This can be written as summation over Cn into psi n of x. What is the proof? Fourier analysis, isn't it? So this is equal to summation over Cn into root of 2 by a sin n pi x by a, and you just find Cn, okay? It's a solved problem. I'm not going to solve it again, okay? Cn, you found that, look at here, 0 for n is equal to 2, 4, 6 and so on, okay? That's equal to 8 by root 15 n pi cube. 8 by root 15, 8 by root 15, no, 8 root 15 by n pi cube, sorry. Is that okay? When n is equal to 1, 3, 5 and so on. Is that okay? Take that out. Now, I mean, we are decomposing this one into, look at here, ground state into first exact state, isn't it? Into second exact state, like that, am I right? We are decomposing this one into psi 1, psi 2, psi 3, like that, am I right? Is that okay? So let me rub out this one. So shall I write like this, psi 3 here, like this, 0 to a, 0 to a here, 0 to a here, am I right? Now look at here, in this decomposition, see again, I am multiplying this curve with C1, I am multiplying this curve with C2, I am multiplying this curve with C3, like that, and I am just adding all of them, I am getting this curve. That is the meaning of decomposition, Fourier decomposition, isn't it? Now in that decomposition, look at here, C1 should be very dominating, isn't it? Why? This curve always looks like same. This is parabola, this is sine curve. Psi 1, sine 1 pi x pi, okay? This is a sine curve, this is parabola, but looks very same, isn't it? That's why C1 should be very high, that you can expect. Okay? And there will be no C2. You can see here, C2 equal to 0 here. This contribution is not there in generating this function. Okay? This contribution is there, but this contribution is too low. Is that okay? That's what I was trying to show in case of the GeoGebra. Okay? Let me share that one later again. Okay? Yeah. Now again, that's why what will happen is, look at here, you found all of this after normalizing. Okay? First, again, you are going to normalize here itself. Okay? You can normalize later also, but the summation over mod Cn square is equal to 1, it will become infinite series. Isn't it? So that's why you can keep A as it is. Okay? You can keep A as it is here. So then later you can normalize. Is that okay? Later we can normalize. So summation over mod Cn square equal to 1. But what will happen? This will become infinite series. So that's why this process of normalization is very difficult in this particular problem. Are you getting my point? Because it's an infinite series. Okay? So that's why we normalize in the beginning itself. Okay? So that later we check whether summation over mod Cn square is equal to 1 or not. That's what checked actually. In example number 2.3, isn't it? In example number 2.3, he's checked again. And anyway, we have normalized this one. I think this is root of some 30 by a power 5 or something, isn't it? We have already normalized that one. Okay? So that's why you don't have to take care about other part of normalization. You can directly go for probabilistic interpretation. Is that okay? So that's why later it is checked whether it is normalized or not. Okay? In the example number 2.3, that's a different story. Now you can go for probabilistic interpretation. Again, that's also example 2.3. So since dominancy of this one is so high in the expansion of this one, so mod C1 square or probability of getting E1 in this state. So that is mod C1 square. It's almost, any idea? 0.9985. 99.8% or 99.9%, can I say like this? Approximately. Okay, 99.8% time. Okay, if you do the measurement on identically prepared system with this state, 99.8% time you are getting ground state. Why? In this decomposition, this is very dominant. You will never get this one, C2 equal to 0, isn't it? What is the probability of getting E2? Mod C2 square, 0, C2 equal to 0, okay? You will never get E2 energy. Okay, this corresponding energy is E1, this corresponding energy is E2, corresponding energy is E3. Okay, what is mod Psi3 square? Probability of getting E3. No, he didn't mention that one. It will be, I think, 0.000 something, am I right? If this is 99%, 0.8, this should be very small. Because you have higher states also, n equal to 5 state also, am I right? That probability is still low.
Whatever we are deriving in Fourier series.
Yeah, again, that psi 5 contribution is too low. Psi 4 contribution is not there in creating this function. This function is created as a linear combination of these, isn't it? Yeah, so can you hear me on YouTube? So that's why 0.00001 or something, okay? Again, you just calculate that one. And probability of E4 is 0, probability of E5 is still lower, okay? So that's why, again, you can go for finding average energy here using all of these C's, isn't it? But that will also become infinite series. Isn't it? That's very difficult now to find average energy, isn't it? How do you find average energy? Summation over En into mod Cn square. n will be equal to 1, 3, 5. It will become infinite series now. You are in the problem. You can't do this one in exam hall because you need to remember some infinite series answer. Am I right? He gave that one. Example number 2.3. You need some infinite series answer. Yes, tell me.
Sir, we say that, but it is less than 1.
We are not measuring position probability. We are measuring energy now. You are talking about position. Total probability of finding the position of the particle between 0 to a, that's equal to 1. That is this probability, am I right? That's how you find A here. Integral psi of x comma 0 mod square 0 to a is equal to 1. This one says total position probability is equal to 1. That's one only, but I'm talking about energy measurement on this one. Are you getting my point? Try to divide that one. Position measurement, momentum measurement, energy measurement, different. This normalization, the basic idea was position measurement, isn't it? Total probability of finding the particle, finding the position of the particle should be equal to 1, isn't it? But here we are talking about probability of finding if you do energy measurement, probability of finding E1 energy, ground state, outcome should be one of the eigenvalue, am I right? We should talk about what is the probability of getting that particular eigenvalue. Are you getting my point? This has nothing to do with that. This is corresponds to position probability, remember. Are you getting my point? Quickly reply.
Yes, sir.
Yeah. So divide that one, okay? So now look at it. But this normalization is same as this normalization. Summation over. I told this one, isn't it? A couple of times. This normalization is equivalent to, what is this one?
CN square equals 1.
Mod Cn square is equal to 1. Am I right?
Yes.
We have seen this one. I think we have proved yes, in the yesterday session, isn't it? But this normalization is backed by energy measurement probability, isn't it? Total probability should be equal to 1. What do you mean by that? I mean, each of them are energy measurement outcome. Either you should get E1, or you should get E2, or you should get E3. Either you should get head or you should get tail, isn't it? That is the idea. This normalization is backed by your position probability. The background behind this one is position probability. Background behind this one is energy probability, but both are equivalent. I mean, both are one-to-one correspondence, okay? You can derive one out of other, isn't it? You have seen that one, okay? Now again observe this one. Now look at here. You are finding average energy. Now this will become infinite series, am I right? Or if you want to find what you call, suppose if you don't want to integrate, suppose if you want to find what you call using this kind of way, if you want to normalize this one, it will become an infinite series, isn't it? Look at Cn. 1, 3, 5 and so on. So that's why this way of normalization is difficult. Don't go for it. This way of finding average value is difficult. Don't go for it. Right now go for it because you have solution in the textbook, okay? But later in exam, then how do you find average energy? Normalize in this way, you can normalize, okay? So do it like this. What is H cap? So particle in a 1D box. Psi star, I'm just putting this psi, okay? Not psi n. So what is this one? P cap square by? Find this value. Are you getting my point? This is outside problem now. In exam, if they ask what is the average value of energy in this state or expectation value of energy in this state, you can't find Cn. After that you can't go for this one. Even after that, if you go for this one, it will become an infinite series. Summation over 1 by n raised to 4, isn't it? Have you seen problem? That's too difficult. You should go for that one. And in this kind of case, look at it. If you want to normalize, you should go for this one. You don't go for this one. To find this one again, you need Cn. Am I right? Go for this kind of normalization. If you want average energy, go for this one. Is that okay? Find the easiest way. Let me divide the problem into different part, okay? Yeah. So this is such a linear combination state. In that linear combination, it contains infinitely many terms, okay? There are two different linear combination states, okay? One linear combination state contains infinitely many eigenstates, this one. And other linear combination state, as other example, it may contain 1, 2, 3 linear combination, 1, 2, 3 eigenstate. You have to divide that problem into branch here. Is that okay? Linear combination state only. Since this is some general function, you have to do a kind of Fourier expansion. It contains infinitely many terms. Yeah. So this problem should be handled in one way. And if linear combination contains 1, 2, 3 terms, that should be handled in a different way. Is that okay? Yeah, let me divide later. Yeah. Now, if you find average energy or expectation value of energy, what value can you guess that one value? With some error? No, you have probabilities.
Probability is there.
Can you guess some values? 99.8% time you get E1.
So it will be almost ground state.
Nearly equal to ground state, just above that one. Okay, if you find this one, look at here, you will get, as I remember, yesterday I asked this one. What is this one? What is pi square value? Pi square value?
Almost
This is exact ground state. This is average value. Either you go with this one or this one. It doesn't matter. Okay. You can go with this step also. You'll get 10 h bar square by 2m square. It's just slightly greater than ground state. This is 9 point something. This is 10. Is that okay? So that's what you can say. Am I right? Your average value will be very nearly equal to E1, but you have 0.0001% of getting E3, E5 and all, isn't it? That's why some measurement will give that one also. That's why average, it will be just greater than E1, but very close to E1. That you can guess, isn't it? Logically.
Yes.
Speak out. I mean, that may be helpful in eliminating options sometimes. Is that okay? If other options are very far away, you can definitely discard them. Okay? Speak out. Yeah. This is such a linear combination state which contains infinitely many terms. Okay? Yeah. Remember. Yes. Mayank.
Sir, even if we add time factor in this wave function, we get same answers.
Yeah. Again, this mod psi x comma t whole square may be different. Okay? But this probability of getting energy, it will not change. I shown last class, last session, last part, isn't it? Again, this Cn along with this Cn, some e power I E n t by h bar may come. Am I right? Along with this one. But mod square is mod Cn square only. Probability of energy measurement outcome will not change in case of even superposition state. Okay? But mod psi square, psi x comma t whole square, that would be different. It's very difficult to find in this case because you have infinitely many terms. Okay? It's very difficult to find here. Okay? So this is about this example. Example 2.3, 2.4 I think you can do. Let me come to 2.5. Okay? This is such a linear combination. It contains infinitely many terms. Infinitely, again, is it composed of infinitely many eigenstates. Okay? Remember. That's why go for integral of finding expectation value. Suppose if they ask, in this case, wait a second. Suppose if they ask, they have given this one. Okay? Just quickly normalize. To find anything, you need to normalize, isn't it? If they ask, what is the probability of getting, what you call, E3? Or what is the probability of getting the particle in psi 3 state, isn't it? After the measurement done on this one, isn't it? Then you go for this one, mod C3 square. Don't go for Cn. Okay? Directly go for what is this C3? 0 to a psi 3 star into psi of x comma 0 dx mod square. Directly go for this one. Is that okay? You know psi 3? Again, remember this should be also normalized, this should be also normalized. Then only this interpretation is true. Okay? If they ask any particular probability, directly go for this integral. Don't go for nth coefficient, then put n is equal to 3. That is what you call unnecessary. Are you getting a point? Depending on the situation, you choose this type. Clear? Yeah. Yes. You are asking something?
Yes, sir. Historical state it's called by twice. We use this case for
No. That operator, it is same for everything. H cap is equal to P cap square by 2m. This definition will not change. Okay, this is whether you take stationary state, linear combination state, operator definition will not change. Okay, is that okay? So that is minus h bar square 2m d square by dx square. I think I told one more technique. Am I right? Do you remember? One more technique. Everywhere, this operator definition will not change. That's what I'm saying. Is that okay? That operator is same everywhere. Okay. Now look at it. I told one technique here. Do you remember? So psi star minus h bar square by 2m d square by dx square of psi dx. Am I right? This can be written as plus h bar square by 2m. One more negative sign will come. D psi by dx mod square. Expectation of kinetic energy. You can say like that. Is that okay? Region of interest, integral over region of interest. This is true in all cases, okay? Have you noted this down?
Yes, sir.
Note this down. Let me prove that one. One of the d by dx2 should be taken here. Its Hermitian conjugate will be -1, so that negative sign will get cancelled. It will be like this. Because what will happen is some function, I'll tell you that problem is there, problem number 2.7. Okay? That will have first derivative discontinuity. Second derivative will not exist at all. Here you need to take second derivative of psi, isn't it? Psi is some general state, okay? I'm not talking about psi n here, okay? Yeah. Second derivative may not be possible. You may need to go for some Dirac delta kind of thing. But in that case, you can use this one, okay? Are you getting my point?
Sir.
Yes.
Sir.
Yes.
So previous step I didn't get, sir. So if we reach to point C3, then sir you are saying that go through the integration. But
Yeah, I mean, now look at here. In the previous part, if they ask probability of getting E3, okay? Why do you find C and then put n equal to 3? Directly find C3, that's what I'm saying. That in integral, while substituting limit everything, you will not get cos n pi, you will get cos 3 pi, isn't it? Sometimes, like that, okay? You will get a direct answer, that's what I'm saying, okay? Yeah, so that's a different story. Just note this down, because what will happen, look at here, in this one you need to take second derivative, okay? In this one you can take only first derivative and you can get it done, isn't it? And mod square should be there. What will happen, sometimes second derivative do not exist, only first derivative. What will happen is, suppose if you have a function like this, that is the function, that is problem number 2.7, okay? So problem number 2.7, okay? Function is like this, okay, psi. So capital psi, suppose, okay? What is d psi by dx? Speak out. Positive slope, negative slope, discontinuous. You can't take second derivative. You need some Dirac delta idea. This one more derivative you can take, it will become Dirac delta actually. Avoid that one. Take first derivative, take mod square, okay? Now you have some 0 to something, something to something, just divide the integral and do the problem. Clear? So that's why this is very, very important, okay? In this kind of situation, if a curve have got sharp edges, if any curve have got sharp edges, okay, so that will have derivative discontinuity. Can you remember that part? Okay, if a curve have got sharp edges, it will have derivative discontinuity. I'll come to that point in Dirac delta problem, next problem, 1D potential problem, okay? Now, this is one possibility. This kind of state contains infinitely many what you call eigenstates. Am I right? Now I'll get into problem number 2.5, where it contains only some state. This is also linear combination state, but it contains very, very less number of combinations, psi1 plus psi2. Am I right? Isn't it? Now, how do you normalize this one? You can go for this way of normalizing. What is this one? Sag x, 0, mod square 0 to a dx is equal to 1. You can definitely go for this one. But that is lengthy. Okay? You have other way, which is easy. Okay? These are individually normalized. They will mention. Okay? These two are individually normalized. Okay? They will mention. I told that one. What is this equivalent to? Summation over mod cn square is equal to 1. Am I right? Now go for this one. What is this one? A psi 1 plus A psi 2. Am I right? Compare this one. C1 psi 1 plus C2 psi 2 plus 0 psi 3 plus 0 psi 4. Should I write that one? No, isn't it? Rest of all coefficients are 0. Only two coefficients are non-zero. What is this one? Summation over mod cn square equal to 1. Or you think like that. Coefficient mod square added should be equal to 1. Okay? Coefficient mod square. Mod a square plus mod a square added should be equal to 1. Mod a square is equal to 1 by 2. A is equal to 1 by root 2. You can take minus 1 by root 2 also. Speak out. Coefficient mod square added should be equal to 1. Look at it. Earlier, in the earlier problem, I went to this step to normalize it, didn't it? Because that was easy. than making this one, because this was infinite series.
Infinite series, yeah.
But in this one, this contains finite number of states. Am I right? This superposition contains finite number of states. That's why I went for this way of normalizing. This way. Is that okay? Find the difference. Okay? Find the difference, because when you see the problem, you should quickly approach in that particular manner. That's why, what is the normalization factor? 1 by root 2. Then find psi x comma t. Isn't it? Just like we do earlier. 1 by root 2 psi 1 e power minus I e1 t by h bar plus psi 2 e power minus I e2 t by h bar. Isn't it? Just like what you do, psi of x comma 0 is equal to summation over cn psi n psi of x comma t. What you write? Cn psi n e power minus I en t by h bar. Isn't it? You do like this. Exactly same. You have only two terms here. You have summation over there. That's the difference. Yeah, this is psi x comma t. Okay, you just have to, just like you do here, you plug in time dependent factor. You have to plug in time dependent factor here. Then find mod psi x comma t whole square. Probability density at later time. Am I right? Okay. So that's equal. That will be time dependent. This is not stationary state. This will be time dependent. Okay. Expectation x, find this one. It will be time dependent using this one. Okay. Similarly, expectation p, you can use this one. Okay. Non-zero. And it will be time dependent again. Check that out. If you measure energy, look at here, part E of the question, 2.5, okay? If you measure energy, what values might you get if you do the measurement on this state, okay? Energy measurement on this state. What values might you get and what are the probabilities? What values you may get here? Speak up. Either E1 or E2, not E1 plus E2 by 2, okay? So again, you may get either E1, measurement outcome should be either E1 E2, okay? So probability of getting E1 is equal to coefficient mod square, mod C1 square, okay? 1 by 2, and probability of getting E2 is equal to 1 by 2. Is that okay? Now what is the average? Okay? Average will be, now look at it, don't go for integral. How do you do? Summation over Cn square into En. Now this is easy. Isn't it? Don't go for integral now. Integral of h sandwich between psi star psi. That's quite difficult. What is this one? 1 by 2 C1 square E1 plus C2 square E2, that's equal to E1 plus E2 by 2. No, look at here. Average energy is some intermediate value, isn't it? It is neither of the, what you call, eigenstate. You will not get this one if you do any measurement, okay? You will get either this one or this one, just like head and tail, okay? Quickly, I hope you can deal with this one.
Sir?
Yes, yes.
Sir, in this question, a particular time is given. That's why you can't go through the array list.
Where particular time is given? Even for later time also, coefficient mod square is same. That's what I told, am I right? E power I theta, its mod square is same. Even for later time also, energy, probability, average, this will not change, okay?
But there is no specific.
Wait, one second.
Sir, array based theorem, sir. Actually, I am talking array based theorem. So psi x comma 0 is given t equals to 0.
Now, wait. You are using this one, psi x comma t, am I right? Whole square to find expectation x, isn't it? Then you can take d expectation x by dt. Multiply with m to find expectation p. You should be taking time dependent wave function. You should keep time as variable. Don't put some particular value of. If you take this one, if you take expectation x in this state, there is no time term. Definitely it will be independent of time. Definitely you will get 0. That's not the way we do. Clear? You should do this.
But sir, after when we evaluate the wave function,
Yeah, again, if you take time dependent wave function, you can use Earnfest theorem. That's it. If you keep time as variable.
Sir, if I normalize that wave function of time dependent, then it will be remain for the whole time.
Once normalization, that was the theorem we taken in the first chapter. Am I right? If normalization is done at time t equal to 0, it is always normalized at all later time. Now look at what do you mean by normalization? Coefficient mod square is equal to 1. Am I right? After time evolution also, look at here, coefficient is this one multiplied with this one, that mod square added 1 only. Isn't it? At time t equal to 0, if you normalize, it will keep on normalized at later time. That's a theorem I have taken in the first chapter. Check that out. Good question. You don't have to think about once you put this factor whether it will be out of normalization. No, it will be normalized only. You don't have to think like that. Okay? Yeah, good question. Now look at here. You may get some I also here. Okay? Psi 1 plus I psi 2. Then also, what you call, if you do normalization, you will get 1 by root 2 here only. So then look at here. Some I will come here, but these probability, these are mod square again. Okay? It will be again the same. Is that okay? Or suppose if you have minus here, you will have minus sign here. But again, these are mod square, am I right? Mod C1 square, mod C2 square, maybe C2 is minus 1 by root 2. Isn't it? Then also these answers are same. Or you may have situation like this, 1 by root 2 psi 1 plus I by root 2 psi 2. Then also mod square, same. You may have 1 by root 2 psi 1 minus 1 by root 2 psi 2 like this. Then also these parts are same. Okay? Observe that one. That's the example problem number 2.6. Do that one. Okay? So he put some e power I pi here. He put different value of pi. What would happen to the state? What would happen to the mod psi square and all? Okay? Yeah. Problem 2.7. Okay. So now this problem again, it contains a into x. I think a into a minus x, isn't it? When x is between 0 to a by 2, isn't it? When x is between a by 2 to a 0 otherwise, isn't it? If you plot this one, is that okay? Normalize this one. Again, while normalization, split the limit 0 to a by 2 to a, because it's a piecewise function, isn't it? Piecewise continuous, isn't it? Problem 2.7. Now in this one, everything is okay. You can find psi x comma t. Okay, you can find Cn, isn't it? Again, if you write this one as summation over Cn psi n, it will contain infinitely many terms. Is that okay? You can find this one. What is the probability of getting E1? You can do those problems. You can find C1 directly, suppose if you need, isn't it? Find the expectation value of energy. Okay? Now comes the problem. If you do Cn and if you go for this way, mod Cn square En, to find expectation value of energy, you will be in trouble because it will have infinitely many terms. Is that okay? Then what would you do? You should go for this one. Even if you do it for later time, it is same, okay? H cap is nothing but P cap square by 2m. Is that okay? Are you getting my point? Yeah. And in that one also, go with this one, okay? H bar square by 2m d psi x comma 0 by dx mod square dx. Why? This has a sharp edge. This has a derivative discontinuity. You can't go for second derivative. P cap square, second derivative operator. Don't go for second derivative. Just told?
Yes.
Isn't it? First derivative is discontinuous. Function, wave function is continuous always. First derivative is discontinuous.
We can put that.
You should go for this one. Take first derivative, define function 0 to a by 2 and a by 2 to a separately, split the limit and do the integral. 0 to a by 2 you will have one type of derivative, positive slope. A by 2 to a you will have other type of derivative, negative slope. Okay, and do the integral and normalize first before going to this one. Otherwise it's meaningless. Okay. Yeah. Yes. Yeah. Problem number 2.8. This 2.8 earlier he defined like this. Particle is equally likely to be in the left half of the well at t equal to 0. That means again you have particle from 0 to a, okay, 1D box. It is equally likely to be in the left half of the well. Okay, that means in the left half of the well your probability density or wave function should be constant, equally likely. We have seen that needle problem.
Yes.
But particle is in the left half of the well. He said like that. Look at here. Particle is not there in the right half of the well in the at time t equal to 0. Okay. Psi of x comma 0 should be equal to. Okay. Particle is equally likely to be in the left half of the well at time t equal to 0. That means he said it is not in the right half of the well at t equal to 0. Is that okay? Problem 2.8. That means wave function is constant between 0 to a by 2. Think over it. Okay. It is equally likely means it is a constant probability density. Is that okay? Equally likely. That's a when x is between 0 to a by 2, 0 otherwise. Okay. Now he is asking what is the probability that energy measurement will give the value h pi square h bar square by 2m a square. What is that one? E1. What is the probability of getting E1? Just find mod C1 square. Just find C1. How do you find C1? First normalize this one. Okay. Psi 1 star into, isn't it? 0 to a. But it will be converted into 0 to a by 2. You can see here, isn't it? What is this probability? Anyone found? He didn't ask anything else, okay? Just this probability. Yes? No, I mean, I'm writing 0 to a. Later it will be converted into, because this is 0 outside a by 2, am I right? It will be converted into 0 to a by 2. That's what I'm saying. But while writing, you should take full region of interest while finding Cn, okay? Are you getting my point? I think 2.9 is whatever we have done in that earlier problem. Example 2.2. Expectation h is independent of time, remember. You can use psi x comma t or psi x comma 0. Both are valid, okay? Now, I'll upload MCQs. So suppose again this psi n of x, am I right? Psi n of x is equal to root of 2 by a sine n pi x by a. Okay, n will be 1, 2, 3 and so on. Okay. Now in this situation, again this is we call this as normalized, am I right? Summation over mod psi n square dx integrated from 0 to a. So that's equal to 1. This is the normalization factor, isn't it? Now, if we start making linear combination like that, C1 psi 1 plus C2 psi 2 plus and so on, okay? So we call this as again psi x comma 0, isn't it? Linear combination state. So these psi 1 psi 2, these are all individually normalized like that, okay? But when you take linear combination, that need not be normalized. That you need to normalize that one. Is that okay? Suppose if you write so 2 psi 1 plus 3 psi 2, where psi 1 and psi 2 are normalized like this already. But if you write a state like this is not normalized. Look at here. So what is the probability of getting E1? 4 mod square? No, that's meaningless. Is that okay? That's meaningless. 4 for probability cannot be 4, isn't it? That you need to take care here. Okay, here. So that's why what I'm saying is, so again, you again, suppose if you end up with this situation, you put a constant and find that multiplicative constant which normalizes this one. Just like we did in case of any function, am I right? Again, we had our solution psi n of x, that's equal to a sine n phi x by a. Then we found that a, so that this condition is satisfied. So similarly, I'm going to find a so that mod a square into 2 square plus mod a square into 3 square is equal to 1. What is a? Speak out. 2 square plus 3, 9 plus
4,
13. 1 by root 13. Is that okay? So if you put, now this is the normalized wave function. 1 by root 13, 2 psi 1 plus 3 psi 2. Is that okay? Now again, there is another way of normalizing this one. 0 to a psi star x comma 0 into psi x comma 0 dx or mod psi square. This one. But that is equivalent to this one. That's what I have shown. Am I right? So this is nothing but summation over mod cn square is equal to 1. This one, isn't it? We have another way of normalizing. So integrate and equate that one to 1. This is also another way of normalizing. But that's quite unnecessary. Am I right? It will contain product term, everything. Isn't it? I think product term you can avoid. Psi 1, psi 2, they are orthogonal, isn't it? That's also not a big deal in case of 2. But this is more easy, isn't it? No need to do any integral. Yeah. So think over it, okay? So for a given particular problem, think over it, what it would be, okay? Now doing this one is same as doing this one, because if you do, you will get to know, okay? You are writing star into star, am I right? Psi 1 star into psi 1 integral is non-zero. Psi 1 star into psi 2 integral is 0 because of orthogonality. So that again coefficient mod square will come here also. Check that out. Is that okay? That's what we proved here. In the most general case, we have proved that one. Okay? Yeah. So this is what you need to get the idea. Yeah. Quickly, any question? Now one more question. I think you might have started. Now can you divide? Look at here. One is stationary state. So again, another one is linear combination state or superposition of state. Superposition of stationary state. In the superposition of stationary state, you have two types, okay? One superposition state, okay, which contain infinitely many terms. Isn't it? Like ax into a minus x kind of function. Isn't it? Like ax, a into a minus x function. Do you remember this one? Yesterday's problems, okay? These contain infinitely many terms. And other one, your initial state, which contain some only couple of terms. C1 into psi 1 plus C2 into psi 2. Full stop. Stationary state, I hope we have discussed enough. I hope you got all property, everything. Okay, mod psi square is independent of time, isn't it? Now, it may contain infinitely many terms, isn't it? Okay, or it may contain only couple of terms. I mean, let me divide the problem.
But in exams are like these actually.
No. There are questions. Look at here. Look at the paper. In JEST and TIFR, there are questions like that. Is that okay? Yeah.
But in CSIR, I can see.
No, in CSIR also, I can show you the questions. I can show you the question. It's not like, I mean, only this kind of question be asked. Now, in this case, these two are normalized, okay? These two are normalized, psi 1 and psi 2. Here we say this is normalized. What do you mean by that? Is mod psi n square integrated dx is equal to 1. We have normalized that one, okay, already. So this, whatever we write, we have to write normalized state. That means if you are writing your particle in a box wave function, you should include root of 2 by a normalization factor. Okay. So now how do you normalize this one? Okay. So now look at here. This way of normalization is very lengthy. Am I right? You will have infinitely many terms. You just normalize like this. Is that okay? But here, if it is not normalized, if again you normalize like this. Okay. In this case, if you want expectation value of what you call energy, so again, I'm discussing particle in a box problem. Okay. So particle in a box problem, not harmonic oscillator or something. So then, so this h cap is nothing but p cap square by 2m. Am I right? Now don't do like this. Is that okay? Don't do like this because it will become infinite series. How do you do? After normalization, you do like this, isn't it? H cap. If h cap contains only p cap square by 2m, I told you the trick. Am I right? What is this one? D dx, isn't it? In case of particle in a box. But here don't do like this. It would be lengthy. Okay. Here after normalization, what is average energy? Summation over mod Cn square into En, or I better write mod C1 square into E1 plus mod C2 square into E2. It need not be E1 psi 1 psi 2, it can be psi 1 psi 3, it can be psi 1 psi 4, psi 2 psi 3, okay, whatever. Even if you have 3 state, then also you can follow the same thing, okay, 3 to 4 state. Find the 2 different situations here, okay, so that when you see the problem, you should quickly know what is the approach, okay. And if any question regarding sudden expansion like that, take the initial state properly, take the final state. You should know what is the range of initial state, where it is 0, where it is non-zero. You should know what is the final state, final wave function. Take the inner product, mod square. Practice this problem.
Can you handle in an orthogonality condition in the new state and the
How, again, look at here, that old states are defined in different region, new states are defined in different region. How do you talk about orthogonality? Orthogonality should be said in one region of interest. Are you getting my point?
Yes.
Are you getting my point? You don't say orthogonality. That's not true. Are you getting my point? In the new box, states are orthogonal. You can say like that. In the old box, states were orthogonal to each other. Okay, old box wave function, new box wave function don't take any orthogonality. We don't say that's orthogonal or something, okay. But in the linear algebra sense, that is true. Yes, speak out.
In the previous question, we have expanded the stationary state as the linear combination of other stationary states. Is it possible?
Now look at it. In the new box, it is not stationary state. That's what I told, isn't it?
Yes, that's right.
In the new box between minus L to plus L, isn't it? It was not stationary state at all. That's why it contained infinitely many terms in its expansion.
Because space is different.
Your whole system became different. He's just what do you call talking about? I mean, he just gave you the function psi x comma 0. Is that okay? But these are actually used, okay? I mean, in the later chapter, in quantum dynamics chapter, he introduced this concept, but we need this one to solve problem right now, okay? Yeah, any problem on YouTube? How to do the integral, that you need to work on. Sin A into sin B, cos A into cos B formula, trigonometry formula, okay?
Which formula, sir? Which question?
No, those 2 questions, whatever I have taken, last integral was sin A into sin B, cos A into cos B formula. You need to apply, and then sin A into sin B. What is sin A into sin B? Half Speak out. What is sine A into sine B?
Cos A minus B minus cos A plus B by 2.
Half of cos A minus B minus cos A plus B. What is cos A cos B? I think cos A plus B plus cos A minus B. Like that? Yeah, that you need to know. Or you can start with sin A plus B cos A plus B formula. Try to deduce, okay? Work on that one. Work on that integral, okay? Because again, if I spend time on that one also, it takes. But if I spend time on that one, again, I can write exam, not you, isn't it? Now, again, one more problem. Look at here. That problem that I was seeing here. Psi of x is given like this. One plus okay, or in case of Griffiths, he has given like that. Am I right? Isn't it? I mean, this looks like our states. Am I right? Again, so particle length from 0 to A. Particle between 0, again, particle is trapped between 0 to A. Particle in one debug between 0 to A, okay? They may give function like this. They may give function like this. Now, these are also linear combination states, but these do not contain infinitely many terms. These contain finite term. Do that one. So, sine, what is sine A into cos B? What is, let's speak out. Multiply and divide by 2. 2 sine A cos B is sine 2A. Look at here. It contains finite number of terms. This is psi 1. This can be written in terms of psi 1. This can be written in terms of psi 2. Which one? Okay, you are talking about odd question. You are talking about odd question. No. Just be there. Sine A into cos A. 2 sine A into cos A. Sine 2A. Not sine A into cos B. Okay, that's different. Okay, is that okay? Now look at here. Now look at here. A sine pi x by A sine pi x by A plus A by 2 sine 2 pi x by A. Now what I need here is I need root of 2 by A here. Isn't it? Now root of A by 2 A into root of 2 by A sine pi x by, because you need to write normalized states here. Speak out. A by 2 root of 2 by A sine 2 pi x by A. That okay? Let me take A also outside. That's the best idea. Okay. Now, so together write it as B or absorb this one to A. Don't keep this one or throw off this one. That's also okay. Isn't it? I have taken common. The whole state is multiplied by root A by 2 now. Isn't it? Okay. So now look at it. I'm going to write it as some B into what is this one? Psi 1 plus half psi 2. If you keep this one, it will be quite difficult for you. Now, what is the coefficient mod square? B square plus B square by 4 is equal to 1. 1 plus 1 by 4. 5 by 4? 2 by root 5? Speak out. 2 by root 5?
Yes, sir.
So that your normalized state will be 2 by root 5 psi 1 plus 1 by root 5 psi 2. Check that out. Is that okay? So again, here you can do lot of things. Look at here. These are the properties. Okay. Now, if you want to avoid this root of a by 2, why can't you multiply with root of 2 by a? You can multiply the whole state with any constant. It will not change any physical property. Later, anyway, you are taking care of normalization. Are you getting my point? Get rid of these terms. Is that okay? You can write it as a only. That root of a by 2, you can absorb to a, and you can find that a, isn't it? Do like this. Be confident. Isn't it? Or while dealing here itself, look at here. While dealing here itself, what you need root of 2 by a. Just throw in root of 2 by a. Whole thing is multiplied by root of 2 by a, isn't it? No physical property will be changed if you do like that. Isn't it? It will be the solution of the same property. Solution of Schrodinger equation with the same property. Is that okay? So that's why while throwing root of 2, just again, if you take only root of 2 by a here, nothing here, that would be wrong. Are you getting my point? If you take root of 2 by a here, nothing here, that would be wrong. If you multiply the whole thing by some constant, so there will be nothing wrong. Is that okay? Are you getting the ideas here? Okay, grab the ideas. Now he has given a sine cube pi x by a. Sine cube theta integral that I asked for you, isn't it? When I took interview, basic math interview for most of you, isn't it? Yeah, sine 3 theta, 3 sine theta minus 4 sine cube theta. Am I right? What is sine cube theta? 1 by 4, 3 sine theta minus sine 3 theta. Substitute that one. A into 1 by 4, 3 sine pi x by a minus sine 3 pi x by a. I hope later you can do, isn't it? Once you got normalized state, later using mod Cn square, you can do any interpretation, you can find average energy. Okay, later part you can do, isn't it? Look at here. I'm very dare to throw a factor. I need that factor here as well as here. That means total thing, I need one multiplicative factor, isn't it? I don't mind. A by 4. So 3 into psi 1 minus, isn't it? Or that is comfortable for you, multiply and divide, whatever. Is that okay? So 3 root of 2 by a that I have taken here. In the whole thing is multiplied, okay? Not individual term. If you multiply individual term, their weightage will be different. Don't change the weightage. Weightage means ratio of C1, C2. That is a probability, remember. Don't change the weightage of that one. 1:3, that should be there. That weightage don't change. Put one constant here, other constant here. Don't do like that, okay? The whole thing can be multiplied, then weightage will not be changed. Is that okay? Weightage, are you getting my point? Or relative values, that should not be changed. Is that okay? That has a physical property, isn't it? Relative coefficients are the physical property, remember. So that's why. So what I did was, I just have taken the root of 2 by a sine pi x by a minus root of 2 by a sine 3 pi x by a. Is that okay? I have thrown the same factor. I mean, the whole thing I have multiplied with root of 2 by a. That's okay. 2 by a. I just throw in the factor. You can multiply a state with a constant, isn't it? That's what I did here. Anyway, later I am taking care of normalization. But don't throw one factor here, other factor here. That will change the relative weightage. This is a linear combination state, am I right? That relative weightage does matter. Ax I cap, ay j cap, isn't it? If you change ax ay, the ratio, it will become other direction, isn't it? It will become other direction of the vector if you change ax and ay ratio. Okay, so just think over it. And now, so that's why this is, again I'll throw off 1 by 4 also. I don't need that one. This is also common, am I right? Or I'll absorb that 1 by 4 to a. It is inside a. You just think like that. Or a by 4, define it as b. In the next step, it would be easy for you, isn't it? That's what I'm saying. Is that okay? A into 3 psi 1 minus psi 3, isn't it? 3 mod a square, 3 square mod a square plus mod a square is equal to 1, am I right? 9 plus 1, a equal to 1 by root 10. 3 by root 10 psi 1 minus 1 by root 10 psi 2, normalized. Speak out. You should do still less step actually. Are you getting my point? And I'm using all properties here. Look at here. Absorbing 1 by 4 to this one. Or throwing in one factor. Or throwing off some factor. These are all properties. Am I right? Unless and until you are not changing this relative weightage, you are not harming the state. Are you getting my point? Relative weightage means, are you getting my point? Look at here. You have a vector here. Okay. Ax, ay. Okay. So ax and ay. Again, your vector A is written like this. Look at here. Grab this idea very carefully. Ax I cap plus ay j cap, isn't it? Now, if you multiply this whole thing by 2, vector length will be doubled. That direction remains same, isn't it? Then later what I do, I'll make it as a unit vector of unit length by dividing by something, isn't it? Later, our idea is to make that vector unit vector, isn't it? I mean normalization. Is that okay? But if you throw off one factor here, ax is multiplied by 2, ay is multiplied by 1, then its direction itself will change. That's the other state actually. That's a new state. Are you getting my point? That's why this relative coefficient decides the direction here, isn't it? Relative coefficient decides the direction. You can multiply with 2, okay? That means 2ax I cap plus 2 ay j cap. Later, so I need a unit vector. What you do? You just divide by magnitude, you find unit vector in that direction. Finding unit vector in that direction is nothing but normalizing here. But if you multiply this one with 2, this one with 3, then that will be some other vector with some other direction. Am I right? This is multiplied by 2, it's multiplied by 3, that will be some other vector, other direction. That will be other state with other property here. Is that okay?
Sir, but normalization constant is different from answer.
Different from?
Sir, Griffith's answer, sir, that we have solved yesterday.
This one not 3 by root 10, 1 by root 10? Check that out, it should be.
The value of a is 4 by under root 5a.
Any mistake that I have done here?
No, sir, after calculation, normalization constant same.
No, after you multiply, I think you will get same, isn't it?
Yes, sir.
Yeah, after multiply, you get same, I think. Check that out. This 1 by 4 also gets cancelled. Have you seen that one? 1 by root 10 remains there, isn't it? Yeah, again, later you will get this one only. But use all properties. That's what I'm saying. Look at here. It's a linear algebra property actually. Relative weightage is important. Okay. Whole thing can be multiplied. Later anyway, you are making it as unit vector kind of thing. Normalizing. Is that okay? Try to compare with that idea. Okay. Yeah. I think now particle in a box topic almost everything is done. 1 or 2 type of problems are there. We shall solve in the separate session.
Sir?
Yes.
Sir, after time when t equal after psi x t square A cos
After psi x comma t.
psi x comma t A cos E minus E3 minus E1 by x plus t expression is coming.
Yeah. Again, yeah, that's correct. This is psi 3, isn't it? I forgot. This should be psi 3. You haven't told. Yeah, that's correct. Again, later everything is same. Psi x comma t, that's equal to 3 by root 10 psi 1 e power minus I e1 t by h bar minus 1 by root 10 e power minus I psi 3 e power minus I e3 t by h bar, isn't it? If you take mod square, you will get cosine of some function. Am I right? That's the earlier problem. Very similar to earlier problem. Now again, here they will ask what is the probability of getting E1? What is the probability of getting E2? What is the probability of getting E2? 0. There is no E2 in the linear combination. Okay, is that okay? What is the probability of getting E3? 1 by 10. What is the average energy? That also they can ask. Is that okay? They don't give this one, they gave that one. Okay, yeah, remember. That was also old question, CSIR question. Yeah, old CSIR question.
The stating follows again.